This is Kosmographia, the Randal Carlson podcast. Welcome back, ladies and gentlemen. This is Kosmographia, the Randal Carlson podcast. And we're going to dive back into more of the climate change stuff. I do want to remind people real quick here up front, randalcarlson.com for everything you want to check for Randal Carlson. Sign up to the newsletter. We got trips and tours coming up, and there is always new stuff happening. So make sure you check the website for new things. But yeah, Randal, where are we going today?
Well, I thought we'd pick up our disclosure on the carbon cycle and the nature of the beast.
All right.
You guys ready for the beast?
I think so.
Yep. Bring it on.
Bring it on. Bring on the beast.
Bring on the beast.
Carboniferous.
Okay, so there's nothing we need to report on as far as bringing people up to date on what's been happening with us and why we've been so neglectful of churning out podcast episodes every week.
Yeah, stuff's happening. Things are busy, but we're trying to get back into the swing of it. So
check the live shows. We really want to use that for the current events kind of things and keep this rolling and give Randal maximum time to present his info. But yeah, we can talk about a few things. There's always tours going on, and there's a monthly newsletter. So that's what we try to direct people to every time. He gives commentary and summaries of latest scientific papers coming out and any tours, any previous episodes that have been released, etc. randalcarlson.com/newsletter will get you there. Just sign up with an email. It'll come the first Saturday of every month.
So, and since the release of our previous episode, we did a presentation lecture in Nashville, another one this past weekend. Which was what, about the 4th? Was it the 4th of March?
March 4th, yes.
March 4th, yes. Let us march forth.
That's right.
To conquer. So March 4th, we did a presentation in Nashville. At the same place we recorded the Sacred Geometry Weekend introduction. And that, we recorded it, so it was not live streamed, but we recorded it, so at some point in the very near future, we'll have that lecture available to people. And I thought it went very well. It kind of segued over into the idea of education and the specific steps that we could be taking now and into the next few years to try to turn this tide of wokeness and everything else, the degradation that has taken over education in America, and get back to an authentic way of bringing people to knowledge. And I think this tour that we've got coming up is going to be interesting. The next Cumberland tour that we've been talking about with people, that by the time this episode comes out, we will probably have already done that tour, won't we, Brad? You think we will?
Oh, yeah.
Yeah, so this now will be in the past. But what I find really exciting about this trip is each trip, it's like the number of young people is growing. So we're going to have 6 kids, ages like 10 to 12 to 13 in there, who are going to be going on this trip with us. And I think it's going to be really great to have that young energy and being able to take them out and tell them the story of these incredible landscapes that we're going to be exploring in eastern Kentucky. So, within a couple of weeks, by the time this comes out, I'm sure Laura will have posted pictures. We'll have probably some video clips from that trip. And it's going to be some amazing stuff. And Brad, you were just up there doing some recon on some of the trip routes, weren't you?
Yeah, definitely. Doing the trails and finding my way around some of the arches and waterfalls that we're going to be going to. Yeah, pretty spectacular landscape up there in the sandstone and the limestone of the Upper Cumberland there in Kentucky. Mm-hmm. Yeah, pretty spectacular. It's going to be a good one.
It's going to be a good one. But by the time you see this, I probably say, yeah, it was really a good one. Because when people are viewing this, it'll be in the past tense. So, yeah, we've been talking about the carbon cycle. And this is something that seems to be conspicuously absent from the conversation about climate change these days. And yet you can't really talk about the role of carbon without dealing with its important function, really probably more important even than its role as a greenhouse gas, which is its role as in photosynthesis. So what we started getting into was how important carbon dioxide is to the health and well-being of plants. And to get into that whole story of photosynthesis and the relationship between carbon dioxide and plants is extremely interesting. And so I think we should just kind of maybe dive into it. I don't have a really precise order for this information, but I don't think we really need that other than just getting into it. And we will kind of try to place it in a historical context as we go. Stop me if we did this last time. I want to pick it up. Maybe it won't hurt to have a little bit of overlap, but one of the early books that I studied or read to try to understand, get a deeper understanding of some of these cycles in nature was back, I probably was mid-'80s. It was a textbook from 1983 called The Economy of Nature, a textbook in basic ecology. So in this book from 1983, the author, Robert E. Ricklefs, speculates, and this is what he speculates. He first lays out the basic idea that organisms need energy to move, grow, and maintain the functions of their bodies. Energy to support these activities enters the ecosystem as light, which plants convert to chemical energy during photosynthesis. The rate at which plants assimilate the energy of sunlight is called primary productivity. It is important to realize that primary production underlies the entire trophic structure of the community. The energy made available by photosynthesis drives the machinery of the ecosystem. The flux of energy through populations of herbivores, carnivores, and detritus feeders, and the biological cycling of nutrients through the ecosystem are ultimately tied to the primary productivity of plants, which is then in turn, end of quote, which is then in turn tied to the uptake of carbon by the plants. Okay. So during photosynthesis, here's what's happening here. You have plants capture light energy and transform it into chemical energy in the form of organic compounds. These compounds may be stored conveniently in their energy later released to meet the demands of biological processes. Photosynthesis chemically unites two common inorganic compounds, carbon dioxide and water. And we know that the atomic structure of carbon dioxide, or carbon, of which carbon dioxide is simply two carbon atoms. Carbon, the structure of that is electrons, protons, neutrons, like all elements. Electrons.
Wait, what did you say about carbon dioxide? Is it CO2, carbon, two oxygen?
Yeah. Well, carbon dioxide is, yes, two oxygen. It's one carbon and two oxygen.
Yeah, okay.
Did I say that? I may have.
No problem.
No problem.
Okay, no problem. But yeah, let's be clear on that. That's what carbon dioxide is. It's a single carbon, two oxygen. The carbon atom is composed of 6 electrons, 6 neutrons, and 6 protons in its non-ionized form. Okay. So again, photosynthesis chemically unites two common inorganic compounds, carbon dioxide and water, and together they form glucose, which is a simple sugar. So the overall equation is you have 6 carbon dioxide molecules. You add to that 6 molecules of water. And what then happens is that is catalyzed by light. 6 carbon dioxide molecules, 6 of water, put those together, catalyzed by light, and then what you get is C6H12O6, which is one molecule of glucose sugar. Plus, you get 6 molecules of oxygen. And this is a key point here. Those 6, you get that 6 extra molecules of oxygen left over. And that's why in the process of photosynthesis, that our extra oxygen molecule is released to the atmosphere. So going on with this. Okay, you got a question?
6 extra atoms of oxygen, or is that what you're saying? Or 6 molecules?
6 molecules, which...
6O2.
6O2.
Okay.
Yeah. So because photosynthesis requires gas exchange across the surface of a leaf, productivity also parallels the rate of transpiration of water from the leaf surface. While I'm doing this, Kyle, maybe you would look up the definition of the word transpiration. Okay? And let's see what that says. I could define it, but let's be precise here. You've heard the term transpiration, right? This is the exchange of water with the atmosphere that goes on by means of the leaf surface. I almost said the lunar surface. I didn't mean that.
So it's the process of evaporation of water from aerial parts such as leaves, stems, and flowers.
There we go. As the moisture content of soil decreases, plants have a greater difficulty removing water from the soil, and so the leaves close their stomata to reduce water loss. Now, do you understand that the stomata are these little apertures in the leaf that take up the carbon dioxide?
Right. And when they're open, they can also evaporate water.
Yes. So, in fact, look up the word stomata, if you don't mind.
I don't mind at all.
So, as the moisture content, so think of this: as the soil dries out, then the plants are having a harder time removing water from the soil. So what they're going to do now is by the apertures that through which water is being lost close down to minimize the amount of water being lost to the atmosphere. All right.
Stomata are tiny openings or pores in plant tissue that allow for gas exchange.
There we go. Okay, so when soil moisture is reduced to the wilting point, leaves are effectively shut off from the surrounding air, and photosynthesis slows to a standstill. So the rate of photosynthesis is therefore closely tied to the plant's ability to tolerate water loss, which is, in turn, to the availability of moisture in the soil and to the influence of air temperature and solar radiation on the rate of evaporation. So humid environments favor high rates of photosynthesis by reducing transpiration from leaves. Okay, so we're going to keep this in mind as we look here at the effects of increased carbon dioxide on the functioning of plants. We'll come back to this idea of the stomata and the gaseous exchange between the leaf and the atmosphere. Okay. So we're going to come forward now to 1987. And this was in the science journal called Tellus, Tellus. I believe it's out of Sweden. Anyway, they deal with a lot of earth science, environmental science, things like that. This was a 1, 2, 3, 4, 5, 6, 7, looks like a 7-person team, which included Roger Revelle. And Roger Revelle was the climate scientist invoked by Al Gore in his Inconvenient Truth, because Al Gore was a student of Roger Revelle. However, interestingly, Al Gore never actually went into what Roger Revelle thought or knew or believed about the matter of climate change and carbon dioxide, and as a medium for heat capture. And when you start getting into that, you discover that no, there's no clear-cut affirmation or confirmation of what Al is saying in the show. So this is where it gets interesting here, because his name is on this study I'm going to quote from here. And the title, this is 1987, the title of the article is Modeling Stimulation of Plants and Ecosystem Response to Present Levels of Excess Atmospheric Carbon Dioxide. So it's a computer modeling, right? Modeling stimulation of plants and ecosystem response. So they're looking at what this increased. By 1987, they're now considering, the role of and effects of carbon dioxide. And so they're attempting this early computer modeling. Ecosystem response to present levels of excess atmospheric carbon dioxide. And this is what they say here. A large number of carbon dioxide stimulation experiments with selected plant communities in controlled or semi-controlled environments suggest that the annual production and biomass accumulation is increased at elevated CO2 concentrations. I'll read that again because it's so important. The stimulation experiments that they did with selected plant types and communities in a variety of controlled or semi-controlled environments suggest that the annual production and biomass accumulation is increased at elevated carbon dioxide concentrations. If CO2 stimulation of net primary production is a real effect in natural ecosystems as well, the dynamics of the presented models suggest that there may be an increase in standing biomass as well as in litter and humus carbon. Okay, they're speculating, and to just strip it of its technical terminology, they're saying that, well, maybe there's going to be an increase in the sheer mass of plants in the global environment, right? There may be an increase in standing biomass. So that includes anything above the ground. But not only the standing biomass, but also the litter and humus carbon, which comprise the ground mass and the soil. Now, so they're speculating. They're doing this computer modeling, and what the computer model is telling them is that the increase in carbon dioxide in the atmosphere is very well going to stimulate an increase in the mass of plants, the increase in the standing biomass. Okay, so now we'll come forward by 10 years to an article by a soil scientist in the journal Science in 1997 entitled Carbon Dioxide and Vegetation. So what happens to vegetation when greenhouse gases, mainly carbon dioxide, increase in concentration and the temperature goes up? The Framework Convention on Climate Change commits the signatories to avoiding dangerous interference with the climate system, interference that might harm the world's agriculture and natural ecosystems. But just what are the likely responses of vegetation? Street Perrott and her colleagues have studied the paleoenvironmental history of high-altitude lakes in East Africa. They examined the lake sediments, the pollen and leaf waxes in them, and the carbon isotope composition of bulk organic matter and of specific biomarkers. They conclude that the increasing concentration of carbon dioxide in the atmosphere since the last glacial period has allowed trees to grow where the vegetation was before 13,000 years ago, restricted to an almost treeless, grassy heathland. Interesting that they use that date from 13,000 years ago, at which point the carbon dioxide is estimated to have been about 180 parts per million in the global atmosphere. But now what they're showing here is that there's the trees are now growing where 13,000 years ago it was treeless. Okay. They're attributing this to the increase in carbon dioxide. Acknowledging that carbon dioxide concentration itself affects the growth of trees enables us to see that the cooling of tropical land was perhaps not so great. During the glacial times, the trees were being starved of the substrate for photosynthesis. Along these same lines, Sage has argued that agriculture became viable at several places around the world between 11,000 and 6,000 years ago, only when the carbon dioxide concentration became sufficiently large to sustain decent yields for our first farmers. For the individual plant, he then goes on and points out that for the individual plant, water use efficiency is almost directly proportional to the level of CO2 for a given regime of temperature and humidity. So, concentrations of 180 parts per million, such as occurred during the late glacial maximum, being half the current levels, would mean that plants had to transpire twice as much water then as now to achieve the same level of photosynthesis. Put another way, doubling the carbon dioxide concentration is almost like doubling the rainfall as far as plant water availability is concerned.
Wow,
Further,
cool.
Increased greenhouse forcing also speeds up the hydrological cycle, and so on average, the actual rainfall increases with increasing CO2 concentration. Both photosynthesis and the enhanced greenhouse effect are more sensitive to carbon dioxide levels when the concentrations are low. The translation of increased photosynthesis to increased growth rate is not straightforward, depending also on developmental processes. However, the effects of the 180 part per million increase from the late glacial maximum to the present 360 part per million. Now, this is in 1997, and it's now at about 406, right? He's returning us now to an idea that we talked about in an earlier episode when we talked about the logarithmic effect of the greenhouse, the logarithmic scaling of the greenhouse effect on terms of increased warmth to the atmosphere. Do you remember that?
Are you meaning like as the concentration of CO2 increases, the amount of heat that it traps is diminishing logarithmically?
Yes, that's exactly what it's talking about. And so he's making reference to that right here. The effects of the 180 part per million increase from the late glacial maximum to the present 360 parts per million should be much greater than the effects of going from 360 to 540 parts per million. The latter, 540, being twice the pre-industrial level. So what was that? The pre-industrial level was, I think he's taking it as 280, probably. Let's see, what did I say, 540? So he's taking that as 270 parts per million as being the pre-industrial level of carbon dioxide. So again, and this is so important in this whole discussion about the role of carbon dioxide in affecting climate change. I'm going to read it again. The effects of the 180 part per million increase from the late glacial maximum to the present 360 parts per million should be much greater than the effects of going from 360 to 540 parts per million, the latter being twice the pre-industrial level. So in other words, pre-industrial, 270 parts per million, you double that, but the effects of that doubling are going to be a lot less. He doesn't go into how much less, but we learned that the decreasing thermal capture ability of carbon dioxide diminishes in a logarithmic scale. So each increment is an order of magnitude less than the previous.
Is he also talking about the effects that it has on plants, or is that not? He's talking about the climatic effect.
He's talking about the climatic effect.
Okay.
Because actually, both, he says both photosynthesis and the enhanced greenhouse effect are more sensitive to CO2 levels when the concentrations are low.
Okay.
So in other words, take down the concentration of CO2, that is going to be, so there, it's an enhanced effect because the increase from 180 to 280 parts per million is going to be a lot more than the same increase of, say, 280 to whatever, or from 400 to 500 and whatever. Because as you increase the amount of carbon dioxide, the amount of heat trapped by it is diminishing logarithmically. And of course, as we've talked about, the way this has gotten around in the computer models of the IPCC is to introduce these positive feedback effects, primarily in the role of water vapor, which is something we should come back and definitely talk about. And we will be talking.
So at low levels of CO2, any increase or decrease has a much greater effect on the warming and cooling than it does when CO2 levels are high.
Yes, that's right. That's exactly right.
Plants are also much more sensitive to changes down at low levels than they are to high. Okay, yeah.
Yes, got it. That's perfect. Great. I'm glad we clarified that.
I have a little question. It's sort of like a side.
Sure.
But I was curious about when you're talking about the grasslands versus later when there's trees growing there in East Africa. Are trees, do you think they're scrubbing more CO2 in general than grasslands?
Good question. And I think the answer is yes. I think they are, because you see, with the trees, you got to think of it that the carbon dioxide is literally combining with water to create substance.
Yeah, it's building the tree.
I mean, the grasses produce a lot of material.
Yeah, this is true. This is a really good question. I probably encountered that somewhere in the studies, but I don't remember off the top of my head. But in terms of if you're partitioning the biomass, say, into trees and grasslands.
From grasses, yeah.
I don't know the answer.
Because I'm curious about the response of the plant life to the different levels of CO2 in the atmosphere. Is this almost like a balancing effect? Like if there's a whole bunch of CO2, then naturally the trees are able to grow, but are they mitigating that increase? You see what I'm saying?
Yes,
because maybe they're capturing more, or
yes,
I'm just curious.
The more plant talk about feedback loops. As the biomass increases, it's just like, think of you're a little kid and you eat, and you're going to eat at what portion that you're going to eat if you're a 3-year-old, how much are you going to eat at a meal compared to when you're fully grown? Well, you eat, and that food that you intake literally gets turned into the substance of your body, and whatever it is, the genetic processes in there that convert that into the substance of your body. As you grow and get bigger, you're going to consume greater amounts of food.
Right. Yeah.
In the same way with the tree.
So the trees has the potential, one that's fully grown, to be consuming quite a bit, I imagine.
Yeah, but it's probably going to be consuming its maximum while it's growing, because it's converting it into substance. And then once it's reached maturity, it'll probably then level off. Wouldn't that make sense? Because now it's not using the carbon dioxide for growth anymore. It's not converting it. Well, it is, because it's still like, if it's a deciduous tree, it's going to lose its leaves, and then it's got to create new leaves.
That's a lot of material again. I mean,
that's a lot of material again, right?
And then, also the other thing that the biomass does is decrease the albedo as well, right? It
would. Yeah, it certainly it would. Yeah, so it's consuming light in a sense.
Yeah.
Okay, so let's go on here. Plants of today are much less water and carbon dioxide limited than they were at the late glacial maximum. Nevertheless, one suspects that the direction of change in the near future will be the same as that following the late glacial maximum, that is, one of increased effective rainfall. Not so much the actual rainfall, but remember the idea that, as he said in the previous one, that doubling the CO2 concentration is almost like doubling the rainfall as far as plant water availability is concerned. So now he's saying that the direction of change in the near future will be the same as that following the late glacial maximum, that is, one of increased effective rainfall, with the agricultural and ecological consequences that follow. Given that the availability of water for agriculture is already becoming such a problem, this aspect, at least, of atmospheric change is a welcome one. Well, yes, it is. You know, what the implication here is that growing things, including anything that's being grown agriculturally, is going to benefit from the increased carbon dioxide. Now, let's jump back to 1992, also in the journal Science, by 3 authors, obviously European climatologists, or let's see, we probably got, I'll look up and see what actually their credentials are, but they're publishing in the peer-reviewed journal Science. Article 1992 entitled Biomass and Carbon Budget of European Forests, 1971 to 1990. So this is looking at the biomass and carbon budget of European forests over a period of 19, almost 20 years. The results of this study then were published in 1992. And here's what they said. The facts about forest resources seemingly contradict the widely held view that European forests are declining. So up to this point, and I can actually remember reading articles and studies in the 70s, even into the 80s, talking about the decline of forests. I have a book on my shelf back there that's the guy is railing on with a doomsday scenario about that within 20 years, the forests of the world are going to be almost eliminated. And so there was this widely held view that globally forests were declining, and especially so in European forests. However, and now that we are doing actual studies, what it showed is that the facts about forest resources contradict the widely held view that European forests are declining. Picking up on the quote, we first elaborate on reasons for the increase of forest resources, and then describe pitfalls in the interpretation of forest health surveys, which have contributed to pessimistic views about European forests. And we don't necessarily need to go into all of that, but they point out that there were pitfalls in the thinking that led to the projections that forests were going to be withering away by the end of the 20th century. Clausen reports that growing stock and timber growth of potential in the United States have been, quotes, and this is quoting this guy Clausen, and anybody who wants to, dive into this for themselves. Again, I'm providing the reference here was Journal Science. It was published April 3rd, 1992, volume 256. So Clausen reports that growing stock and timber growth potential in the United States have been, quote, repeatedly and seriously underestimated, end of quote. An increase of forest resources can be explained by factors such as silvicultural developments, favorable climatic conditions, because let's remember, between 1892 and 1992, the climate has warmed. Over the last 150 years, the climate has warmed out of the Little Ice Age. And that warming has made a positive contribution to plant growth, okay? An increase of forest resources can be explained by factors such as silvicultural development, favorable climatic conditions, the fertilization effect, and they're admitting it here now in 1992, but they're not quantifying it. They're merely admitting it, but not quantifying that the fertilization effect of additional carbon dioxide in the air and the deposition of plant nutrients. So they've pointed out that there's a series of things, silvicultural development, which is basically the science of growing trees, right, of growing and managing forests. That's essentially what silviculture is. So you got that. You've got favorable climatic conditions, which easily refers to the increase in warmth over the last century and a half. And then they say the deposition of plant nutrients, which is all a consequence of the preceding. But the key here, takeaway, is that it's also included in that is the fertilization effect of additional carbon dioxide. So then we also talked last episode about the mismatch of sources and sinks, that there is more carbon dioxide being taken up than the models suggest should be taken up. This is from also a 1992 article here. Actually, it's the same one, of the biomass and carbon budget of European forests, and they're pointing out this mismatch of sources and sinks. You know, a source is somewhere that carbon dioxide is coming from, and a sink is where it's ending up. You know, is that sink going to be in biomass? Is it going to be in the oceans? Is it going to be ultimately the ultimate sink, as we found out in the previous episode, was the carbonate rocks? And we found out that there's a huge amount of carbon dioxide locked up into the limestone rocks. Global carbon budgets have been constructed taking into account emissions of carbon dioxide from deforestation and fossil fuel consumption, absorption of CO2 into oceans, and the buildup of CO2 into the atmosphere. Budget calculations have remained incomplete since the estimated annual sinks appeared about 1.2 billion tons of carbon too low. Budget calculations have remained incomplete since the estimated annual sinks appeared about 1.2 billion tons of carbon too low. Our data indicate that European forests accumulated 85, and here you go, Kyle, in the European forests, accumulated 85 to 120 million tons of carbon per year in the 1970s and 80s. This alone represents 8 to 10% of the missing flux in the global carbon budget. If global or universal mechanisms play a role in Europe, similar biomass accumulation should have occurred in other continents. And then they conclude, part of their conclusion, they're saying that despite air pollutants, which were still more of a problem in the early 90s, but certainly in the 70s and the 90s, that there were actual air pollutants that could affect plant growth and are known to affect plant growth. In spite of the air pollutants, forest resources have increased in Europe. In summary, we estimate that growing stock and forest growth in Europe increased between 1971 and 1990 by 25 and 30%, respectively. This information seemingly contradicts the commonly held view of forest decline in Europe.
That's a lot.
That's a very, yes.
Yeah.
It is.
I think it's declining, and for it to increase 25 to 30%, that's a huge.
Yes.
Yeah.
And in fact, this has been going on all over the world for the last 30 or 40 years. It was not even realized. Well, there was a lot of, one of the things that changed was we started getting satellite surveys of the actual amount of land covered by forests.
So what is that, just real quickly, what does that look like? Is the forest increasing in size and geographically, or is it just growing more trees within?
Both. Both the above.
Okay. So the forests are slowly creeping closer to people's houses, and no one notices.
That's what
they all think that they're dying out. I mean, it's strange. I'm just trying to imagine what's happening.
So the year before, Sherwood B. Idso, who is a scientist that has probably devoted more years to the study of the role of carbon dioxide, his son maintains a really great website, following in his father's footsteps. This was a 1991, so what, 32 years ago, 33 years ago, by Sherwood B. Idso. It was published in the Bulletin of the American Meteorological Society in July of 1991. The title of the paper is The Aerial Fertilization Effect of Carbon Dioxide and Its Implications for Global Carbon Cycling and Maximum Greenhouse Warming. And this is what he has to say. The question of ultimate surface temperature increase thus comes down to one of estimating the maximum amount of CO2 that man is likely to release to the atmosphere in the years ahead. A doubling of current emissions, for example, would lead to an atmospheric CO2 content on the order of 700 parts per million, which would probably be climatically acceptable, but only if Earth's forests are not decimated in the meantime. On the other hand, if the forested area of the globe could be increased, even greater quantities of carbon dioxide could safely be released to the atmosphere. In this regard, nature becomes our ally, as increases in atmospheric carbon dioxide result in growth rate increases of trees 5 times greater than growth rate increases in non-woody plants. So there we go, Kyle. Did you get that?
I got it.
There's
and I remember you showed the study of the guy, that he had the trees in the pots, and, he had one control and the other ones with different higher concentrations. They just grew way faster. Yeah. But grasses, they don't grow faster. You get the same amount of hay.
Well, the growth rate increases of trees 5 times greater than the growth rate increases in non-woody plants.
Yeah.
As a result, the carbon dioxide content of the air continues to rise. Hence, as the CO2 content of the air continues to rise in the years ahead, woody species will begin to expand their ranges, as is already happening in many parts of the world.
Now, so isn't this is just land based though, right?
Yes.
There's ocean algae that is massive in this exchange as well, right?
So the result of these studies, now, disclosure here, these studies for me were 10 years ago, but I think that the conclusions and the data is all still valid. It's probably been tweaked somewhat, but yes, this missing sink where half of the released carbon dioxide into the atmosphere was not accounted for 30 years ago is being taken up through a combination of ocean and land biomass.
Okay, yeah.
Now, the exact partitioning percentages, I don't know. They've probably refined those numbers since I was doing this research, but probably not hugely. But the point is that, both the ocean and the plants are taking it up taking up the additional carbon dioxide. And see, this is the thing about how this carbon dioxide pump works, is because you increase the algae, you increase the planktonic and benthonic feeders of the increased biomass in terms of algae and so on. And then all of these, single-celled and small microscopic creatures are converting that carbon dioxide into their shells. And then when they die, their shells go to the bottom, and ultimately, unless something, stirs them up and sends them back up, and so their shells are, like an impact may do it, probably would release a lot of the carbon dioxide back into the atmosphere. But barring that, or maybe a volcanic eruption on the seafloor, barring that, this stuff is all getting converted back into rock.
Yeah, into stone, right.
And once it turns into rock, now it's taken out of the cycle for hundreds of thousands to hundreds of millions of years. And that's why we found pyramids. that it's what?
It eventually becomes pyramids.
And eventually becomes pyramids. Yeah. That's right.
Pyramids are built out of CO2, folks. You need more of it.
So, okay, so now jumping forward to 1997. The quote I just read was from 91. So 6 years later, the British Journal of Science Nature published this paper entitled Increased Plant Growth in the Northern High Latitudes from 1981 to 1991. Variations in the amplitude and timing of the seasonal cycle of atmospheric CO2 have shown that an association with surface air temperature consistent with the hypothesis that warmer temperatures have promoted increases in plant growth during summer and or plant respiration during winter in the high latitudes. Here, we present evidence from satellite data that the photosynthetic activity of terrestrial vegetation increased from 1981 to 1991. The winter and spring warming in the interior of the continents of Asia and North America in the 1980s may be a result of natural causes not yet explained, but its timing is consistent with an enhanced greenhouse effect caused by a buildup of infrared absorbing gases in the atmosphere. Now, notice he's saying it could be that, but it also could be natural causes not yet explained. And later on, as we go forward with this and circle back and take a more in-depth look at the sun, I think we're going to be able to say that, yes, we can now explain some of those natural causes after 30 years of solar observations or 25 quarter century of solar observations since this paper was written. Okay.
Yeah.
So the timing is consistent with an enhanced greenhouse effect caused by a buildup of infrared absorbing gases in the atmosphere. Although it amounted to a departure of only a few tenths of a degree from previous record temperatures, it was associated with far greater warming in the spring months at high northern latitudes. Biospheric activity there, based on our analysis, increased remarkably as a result of this warming. In other words, biospheric activity. In other words, the health and vigor of the biosphere increased remarkably in that 10 years. That's something to keep in mind, and that I think is probably being de-emphasized.
Yeah. I think it is. You want to take a break real quick and
Sure.
come back? We're right at a break time. Okay.
Let's do it.
All right. We will be right back.
And welcome back, ladies and gentlemen. Kosmographia. Wow, that beer looks good, Brad.
Got a screwdriver.
Man, rushed break this time.
Welcome back, everybody. We're just going to jump right back into the topic at hand here. Take it away, Randall.
Well, I'm sure that all of you guys have read the paper that appeared in 2007 by R.A. Houghton in the Annual Review of Earth and Planetary Sciences entitled Balancing the Global Carbon Budget.
Oh, yeah. I read it at least 3 times.
It's on my toilet.
If it was in the essay Redemption of the Beast, yes, I did.
I'll bet it was. So, Brad, you get an attaboy there.
I've read Redemption of the Beast.
Then you have read it.
Okay, good.
Yeah, excellent. All right. You guys are not disappointing me. I like that. Of course, now that was you that said that, right, Kyle? Because I'm not actually looking at the screen.
No, that was Russ.
That was Russ.
You still can't tell us apart. We sound the same. It's all right.
It is difficult sometimes.
Okay. So anyway,
no wonder he's always giving me shit.
The Annual Review of Earth and Planetary Sciences, Volume 35, published in 2007, page 313. Actually, this quote's from page 325. The paper went from 313 to 347. So experiments have shown that C3 plants, now there's C3 plants and C4 plants, and that refers, and I'm not going to get into that because I want to move along at a pretty good pace here. It's just the photosynthetic pathway that it's referring to. And
pull the microphone up a bit, Randall. Sorry.
And some of the photosynthetic processes of some plants are geared more to drier conditions, and some are geared more towards moisture conditions. But C3 plants are the important ones as far as human well-being, because it includes all trees, most food crops, and vegetation also in cold regions. So experiments now have shown that most C3 plants respond to elevated concentrations of carbon dioxide with increased rates of photosynthesis, increased productivity, and increased biomass. So the plants that include most of the plants that we eat, they respond to elevated concentrations of carbon dioxide with increased rates of photosynthesis, increased productivity, and increased biomass. The biomass response to elevated carbon dioxide averages between 20 and 30% based on measurements from more than 100 experiments. The pools of carbon in the litter and soil carbon also increase under elevated CO2. Warmer temperatures and changes in soil moisture often favor the growth of trees, and in the longer term, the spread of trees into tundra, savannas, and grasslands. So there, we're gaining trees at the expense of grasslands, Kyle. Increased temperatures in cold ecosystems, for example, in tundra and taigas, increased productivity and carbon storage. Increased temperatures in cold ecosystems, increased productivity and carbon storage. And then he states the obvious. One aspect of warmer temperatures is a longer growing season, as observed now over the boreal zone, which is the northern zone, and temperate Europe. So this is one of the things that has been observed in perhaps the last 50 years, is that along with the warmer temperatures that have, say, a degree centigrade in the last 100 years roughly, one aspect of warmer temperatures is a longer growing season. And this has been observed in both northern, that is boreal zones, and in temperate Europe. So the factors described above often interact non-additively to influence carbon storage. For example, high concentrations of CO2 enable plants to acquire the same amount of carbon with a smaller loss of water through their stomata. Did you get that? High concentrations of carbon dioxide enable plants to acquire the same amount of carbon with a smaller loss of water through their stomata.
I wonder what that amount of water is like on a global scale, because that would be interesting, because water vapor being a greenhouse gas.
Mm-hmm.
So again, you're reducing the amount of water vapor entering the atmosphere.
Yes.
Because their stomata are not losing so much water to the air.
Right. So he goes on to say here that this increased water use efficiency reduces the effects of drought. Higher levels of carbon dioxide may also alleviate other stresses in plants, such as high temperatures and ozone. The observation that productivity is increased relatively more in low productivity years suggests that the indirect effect of CO2 in ameliorating stress may actually be more important than the direct effects of CO2 on photosynthesis. Carbon dioxide and nutrients may also interact synergistically to increase carbon storage. Nitrogen fertilizer and elevated CO2 together had a greater effect on forest growth than the sum of their individual effects. And further, this relative stimulation was again greater in a nutritionally poor site. In other words, the lower the health of the biosphere, the more effective the carbon dioxide is in producing an improvement. So
yeah, and I would imagine that the effect that the increased carbon dioxide has on the efficiency of water probably is what also allows the plant to more efficiently utilize like nitrogen and stuff, the micronutrients from the soil.
Yes. Okay, so now here's from a study that appeared in the New Phytologist, volume 139, issue 3, July 7th in 2008, entitled Tree and Forest Functioning in an Enriched CO2 Atmosphere. Forests exchange large amounts of CO2 with the atmosphere and can influence and be influenced by atmospheric CO2. There's been a recent proliferation of literature on the effects of atmospheric CO2 on forest trees. More than 300 studies of trees on 5 different continents have been published in the last 5 years. These include an increasing number of field studies with a long-term focus and involving CO2 stress or environment interactions. The recent data on long-term effects of elevated atmospheric carbon dioxide on trees indicate a potential for persistent and enhancement of tree growth. Recent studies indicate that elevated CO2 causes a more persistent stimulation of biomass increment and photosynthesis than previously expected. That's a good one, because in all the environment and the promotion of the narrative, those recent studies that are being cited here were conveniently ignored. But I'm going to read it again. Recent studies indicate that elevated CO2 causes a more persistent stimulation of biomass increment and photosynthesis than previously expected. In other words, the beneficial effects of carbon dioxide on the biosphere are greater than they had imagined. And now I'm going to do a quick screen share here, if I can find you guys again. I open a screen here, and then you guys get hidden. And I have to go looking for you. Here we go. Okay, let's let me go put this onto presentation mode. Hang on just a second. All right. Are we seeing this graph here of U.S. forests?
We are.
Got it.
All right. Here we go. U.S. forests. Now, this is from, so this is already 20 years old. So it's actually increased considerably more than this study since the 20 years that this study was published. This says here, this is the inventories of standing hardwood and softwood timber in the United States compiled in the Forest Resources of the United States in 2002 by the U.S. Department of Agriculture Forest Service. So you can see there's a very obvious linear trend cited in 1998 with an increase of 30%, and that has continued. The increase is now 40%. The amount of U.S. timber is rising almost 1% per year.
I wonder what caused that drop right there in the right at 1990. Little dip.
Yeah, there is a little dip right there.
Yeah.
And there's probably an interesting explanation.
Yeah.
And I don't know what it is, except that would have been about 1988. So interestingly, that would have been about the same year that, Congress met to establish the IPCC. 1988 was when James Hansen made his presentation to Congress about the scary narrative about increased carbon dioxide and global warming. But notice the y-axis over there, hardwoods and softwoods in billions of cubic feet.
Well, I mean, I don't know if I can trust this source, but I'm just looking at a headline here. Global deforestation peaked in the 1980s. Maybe.
There we go. That's probably it right there. So that could have been deforestation. And then you'll notice here, as you get to the top square, it's actually shifted over to the high side of the linear trend. So that probably is what that is. That's probably deforestation. But in spite of the deforestation, between 1950 and 2000, the amount of 40% increase in cubic feet. So we've gone from 600 billion cubic feet to looks like about 860 billion cubic feet. I'd like to update this and get a more current estimate. I'm sure that would be easy enough to do, but I would guess that the linear trend has probably continued right on. And then this one is an interesting graph. Over here, notice you've got on the y-axis is the percent growth enhancement. So, down here, zero growth. And then as we come up here would be a 200% growth enhancement and a 320% growth enhancement. And here's on the x-axis, you've got your atmospheric CO2 enrichment. And notice it's going from 0 up to, what is that, about 1,350 parts per million, 1,300, about halfway between 1,200 and 1,500. So your blue is your healthy plants, and your red is your not healthy plants. So this is the data summarized from 279 published experiments in which plants of all types were grown under paired, stressed, open red circles, and unstressed conditions. There were, we don't need to get into all of that, but the plant mixture in the 279 studies was slightly biased toward plant types that respond less to CO2 fertilization than does the actual global mixture, which means then that this graph is very conservative in terms of the beneficial effects on plant stress with respect to increased or enhanced carbon dioxide. As it says, therefore, the figure underestimates the expected global response. CO2 enrichment also allows plants to grow in drier regions, further increasing the response. So in other words, the plants that are stressed under various conditions are affecting more to the enhancement than the plants that are already healthy and don't really need it. And there's a number of different kinds of things that can stress plants, the obvious being a drought. The other, of course, can be various kinds of infestation. And so I'm going to stop share there. But
also,
again,
point, Mount St. Helens went off right at 1980.
I was wondering about that, too.
And it, like, obliterated tons of trees. So I wonder if that maybe, you don't think that's enough?
I don't think it's enough. I know. It a lot regionally, I'm sure it would have had effects. Yeah, because it did obliterate what, like
well, I was just looking at 500. I was trying to find the numbers, how many acres or whatever, but they did say more than 4 trillion board feet of timber were destroyed or damaged by the lateral blast. That's 9,400,000 cubic meters of wood. That's a lot of trees.
That is a lot of trees, yeah.
And then there was this massive ash fallout that drastically reduced forest growth and health in various areas. So, I mean, who knows? Maybe it did have a long-lasting effect that resulted in, I don't know. But it is interesting that it happened right at 1980.
When you stand there in the park overlooking the mountain that's 5 miles away and you see the side flank of it blasted out, you really get a sense of it was a huge event. And lots of trees were blasted down, and they're still visible, just strewn out in that blast pattern all around the area.
All right, let's come back to Sherwood B. Idso. And the Bulletin of the American Meteorological Society. He pointed out that, considering the fact that carbon dioxide is the primary raw material used by plants in producing organic matter via the process of photosynthesis, and that the more carbon dioxide there is in the air, the better plants can perform this vital function, even under conditions of limiting light, water, and nutrients. 3 things that can cause stress in a plant: limiting the light available, limiting the amount of water, and limiting the amount of nutrients. This being the case, as literally hundreds of laboratory and field experiments have clearly demonstrated, the carbon dioxide sequestering ability of the world's plant life should rise right along with the CO2 content of the atmosphere. And at some future date, it may be possible that it will have risen high enough to offset man's perturbation of the global carbon cycle and yearly remove from the atmosphere all of the CO2 that we yearly put into it, which would stabilize the carbon dioxide content of the air and prevent it from rising further. So then he goes on to some specific experiments that were done. I'm not going to get into all of the background. I'm mostly going to just jump to the conclusion. Just a few points. That there was an experiment that was begun in July of 1987. And so you had 8 genetically identical, 30-centimeter tall sour orange tree seedlings planted. So I think we did touch on some of this, but just kind of a very quick review. There were enclosures made, open top chambers. They had transparent walls. Air entered the bottom of the enclosures through perforated plastic tubes and exit them through their open tops, exposing half of the trees to the current concentration of atmospheric CO2 and half of them to a CO2 concentration 300 parts per million above the current value. Okay? Except for this one difference. The 2 sets of chambers have been treated identically from the start of the experiment. So over the past 3 years, several independent assessments have been made of the growth of the trees, which now stand 3 to 5 meters in height. The net result of these differences in physiological response has been dramatic. After 2 full years of growth, an assessment of the volumes of the tree's trunks and branches revealed that the CO2-enriched trees contained, and we did cover this, but it's important, so reviewing it, revisiting it is a good thing, that the CO2-enriched trees contained 2.8 times more above-ground sequestered carbon than did the ambient treatment trees. 6 months later, a similar assessment of below-ground growth revealed that the CO2-enriched trees also contained 2.8 times more root-sequestered carbon than did the trees grown in the ambient air. And I showed that picture of the side-by-side trees, didn't I? We did that on the episode, right? So I don't need to review that. So here's kind of how he concludes here. As vegetative productivity increases simultaneously over the entire planet, humans will harvest greater quantities of organic matter from each unit of land, thereby alleviating the pressures that currently lead to the felling of forests. As the rising carbon dioxide content of the atmosphere thus provides a strong impetus for forest expansion, it likewise provides a solution to any problems its continued upward trend might produce, as it intensifies the major mechanism responsible for its removal from the air, operating in true Gaian fashion. It would thus appear that the planet can care for itself with respect to CO2 climate considerations. Hence, there is every reason to believe that if we adequately clean up our industrial technological act, we need not bring down the curtain on it. And then I'm going to jump here to another share screen.
So he was just basically saying, if we can clean up the pollutants that we make, we don't need to worry about the CO2 because the earth can handle this and the plants will,
That's exactly what he said.
Okay.
Okay, so here are we seeing enhanced wheat yields in a carbon dioxide-enriched environment?
We are.
We're good. Grain yield, kilograms per hectare. And you'll notice here in these studies that in all cases, so here's your grain yield, and you've got 370 parts per million and 550 parts per million. Now, 370 parts per million, we've passed that by about 35 parts per million. We've not reached 550 parts per million. But look at the increase in your dry wheat, a 21% increase in yield. Your wet wheat, 8%. And then notice here, you get the next year, 93, 94. Look, your dry wheat is increased by 25%, your wet wheat by 12%. So here's wheat as an example on a specific type of plant. Here you're looking at calculated growth rate enhancement of wheat, young orange trees, and very young pine trees already taking place as a result of atmospheric enrichment by CO2 from 1885 to 2007. That's in A. Okay, so here you've got your production normalized to 295 parts per million. So your orange here, 295 parts per million. So this would have been, pretty much at the beginning of the industrial age. And then at 383 parts per million, this was where it would have been, 10, 12 years ago.
Yeah, so it's easy with those graphs to see that the trees have a much larger benefit.
Yeah. Look at your young pine trees.
Yeah, the wheats, the grasses versus the trees.
But in every case, there's an increase in growth rate. So pretty amazing, actually. And I find it very interesting that, people just don't know this. I got a graphic here I'm going to pull up. A photograph. Let me get it on the other monitor, and then we'll pull it over. Let's see here. Here we go. Here's it. So this is showing a succession of pine trees of the same age and grown under identical conditions, except for the addition greater concentrations of carbon dioxide. So you'll see in this photograph.
Share it.
I'm about to do that.
Okay.
Here we go. So you'll see in the photograph on the left is ambient. Are we seeing Sherwood?
Yep.
Here he is. Ambient. In other words, this is what's in the atmosphere now. Now, same conditions, same length of time, same everything, except for carbon dioxide enhancement. Add 150 parts per million to the current. Notice that tree. Add 300 parts per million. Here's adding 450 parts per million. The tree on the left is grown under ambient concentration, and the trees to the right with enrichment above ambient as shown. You don't see this being
nope.
publicized, do you?
It's not.
No, because they don't want people thinking about the fact that there's a whole other side to this equation. I think we've already shown, without being exhaustive, we've shown how the deception has worked statistically, how the statistics are manipulated to make it look as if, tornadoes and hurricanes and fires and all of this have increased when in fact they have not. We've also seen here that not only is there deceptive manipulation of the statistics to create one impression, it's a selective in that there's a whole lot of this story that's being left out, that's not being addressed, and people don't know this. Well, do you think it's important to know this if we're going to be discussing? Because ultimately the idea is our emissions of carbon dioxide is creating a climate crisis. And literally, we have groups of people. Now, there was just a story today about somebody who was, vandalized one of these, that are vandalizing the works of art and stuff. Did you catch that? I don't remember which one it was.
Yeah, I've seen those.
There's been a new flurry of them in the last couple of days.
Oh, okay.
These are people, and there's a whole lot of them out there that literally have bought into the notion that we have to shut down industrial civilization. And that, of course, is the clear implication if we say we're going to stop using fossil fuels, zero fossil fuels, leave them in the ground. We've got to shut it all down. And there is no discussion. There's no comprehension of, one, what that means in terms of what does that really imply if we are no longer using fossil fuels. Very few people that are promoting that narrative are even stopping to think, well, wait a second, what does that mean? So
what
there's
they're
that.
Doing without stopping to think, sorry to interrupt, Randall, but
go ahead.
They're supporting the whole idea of population reduction to very small numbers without even knowing it.
That's, yeah.
Yes,
some of them
without even
know
knowing it. Without even knowing it, yes. It would absolutely lead to a global mortality event of an epic scale.
Right.
It would. And here's the irony of it. It would have no effect on the climate.
Exactly.
And the other part of it is to push this narrative, to create this fear, this environment of fear and anxiety over, anthropogenic climate change. You have to ignore all of the stuff that we're looking at right here. You have to ignore the fact that the heating, the greenhouse effect of carbon dioxide at 400 parts per million is nearly exhausted. You have to ignore that. And then you have to ignore the fact that the increased carbon dioxide in the atmosphere is fueling a literal regeneration of the biosphere. It is literally doing that. And people are failing to put the context in, and that throughout the 2 million years of the Pleistocene, Planet Earth has been in a severe carbon dioxide drought, the lowest concentrations of carbon dioxide since the beginning of the Cambrian. We've looked at those graphs. We've seen that. So, again, there's no context to even have this discussion in most people.
Let me ask a question before you switch the slide here.
Sure.
Because I don't know. This is showing it's pine trees, right? So they've got needles. I don't know how that compares to the stomata, the stomatal apertures on a leaf.
Well, I
would think that a leafy plant would be even more advantageous from this.
In the graph, he showed pine trees got the most advantage.
The best, yeah.
Did it? Okay.
Well, yeah, orange
I agree
trees.
with the question, like where are the stomata on the needles versus the deciduous trees? Like, but it did show that the pine trees had the best benefit for increased CO2.
Okay.
Yeah.
Okay. Yeah. It was 248% for young pine trees, and it was 111% for orange trees. Now, I guess orange trees are deciduous. I'm assuming
they have stomata.
They have stomata, yeah, but
leaves.
They have leaves.
No, I'm just talking about the pine tree needles.
Oh, the pine trees, yeah, of course they do.
I was also fascinated with this, their method here. This is a bit of an aside, but because of how carbon dioxide works, they just did these open-topped boxes out in the field.
Mm-hmm.
I looked at pictures of where they were doing the study, and they just put in 4 posts and wrap it in plastic. And then as long as you keep the CO2 concentration inside the box, it's heavier than air, so it sits on the floor. You don't have to worry about it rising out of there. Now, I guess if it gets windy, it'd get blown out of there. But in general, you can do an open box treatment for increased CO2.
Yeah. So quickly, we'll go through just a few other things here. Let's see here. Okay, this is a good one. This is a photo. I'll do a screen share again. I'm getting good at this screen share stuff.
Yeah, there it is. See how they're all open topped.
Yep, there it is right there.
Yeah.
And what we have here is...
I wanted to try this in the vineyard.
Oh, that would be a cool experiment.
Yeah.
The following photo from their article, and that's this, the effects of increasing atmospheric CO2 on vegetation, which appeared in the journal Vegetatio in 1993. The following photo from their article shows the author's CO2 enrichment chambers at the United States Department of Agriculture, Agricultural Research Service, U.S. Water Conservation Laboratory in Phoenix, Arizona. So that's it right there. So here is a 64% increase in cotton yield for the same amount of land. Is remarkable and has important implications for future conservation measures. So what about other species of vegetation? The author of this paper referred back to Kimball's 1883 study from which I quoted earlier. Kimball assembled and analyzed much of the existing data available in the literature in 1983 about the yield or growth response of 37 species of plants to CO2, amounting to 430 prior observations. The average response was a yield increase of about 33%. Curie assembled the available data about the carbon exchange rate, which is a measure of net photosynthesis, biomass accumulation, yield, and other physiological parameters of 10 major crops: wheat, barley, rice, corn, sorghum, soybean, alfalfa, cotton, potato, and sweet potato. The results of her analysis were close to the 33% reported by Kimball. So, in all the food we eat is growing and proliferating under carbon dioxide enrichment. It is gaining greater resistance to stressful conditions. It is also having much more efficient water use, and it's also increasing the yield of these plants by a third.
Doesn't it also help them with pathogens, diseases?
Oh yeah, let me show you an example. I've got one right here.
Because that might decrease the need for various sprays.
Yeah, let me.
So people that don't like, pesticides or various, fungicides or fungicides that get sprayed on plants, increased CO2 may increase their resistance to those kinds of things and lessen the need for such sprays.
Yeah. Did we look at the effects of increased ozone poisoning on plants?
I think so.
We did, yeah.
Yeah, that's a good example. We can pull it up and review it very quickly here because, yes, CO2 makes plants healthier and more resistant to all kinds of things, all kinds of stressful conditions. Where did that go? Let's see here.
Yeah, I mean, and that seems like a given when
it is right here.
Somebody is like nutrition, they're going to be way more likely to get sick, all that sort of thing. So if you're
okay, so here we go.
Eating well, typically the immune system's working better.
Yeah. So, here we're looking at ozone damage on leaves of American linden or basswood tree. And you'll notice, you see here how look at this leaf right here. Okay, that's ozone damage. You can see here that they're turning brown and they're starting to wilt. And then down here, this picture is muskmelon leaves showing damage from ozone pollution. So here's the study. There is another benefit to...
Yeah, we did look at that.
We did, yes. And we looked at the Missouri Botanical Garden. And so it definitely helps plants. They're more resistant to the effects of ozone poisoning. So let's see. Yes, here was the study, 1998. Elevated carbon dioxide ameliorates the effects of ozone on photosynthesis. Species respond similarly, regardless of photosynthetic pathway or plant functional group. So this, remember I mentioned that you had the C3 plants and the C4 plants, which are the two photosynthetic plant pathways, photosynthetic pathways. So they both, in both cases, both types of plants responded favorably to the increased carbon dioxide. So let's see. Here's a quote from the article. In industrial regions, current ambient levels of ozone reduce photosynthesis in many and probably most plant species. Chronic ozone pollution commonly results in increased respiration rates, shifts in carbon allocation, decreased leaf retention, and shortened leaf longevity. And current levels are known to be high enough to reduce the growth and yield of agricultural crops and trees. And then I comment regarding their article, after discussing their material methods, the authors report on the results of their experiments, and the results proved quite remarkable. The first thing they noted was that, quote, in all 6 species used in this experiment, plants grown at ambient CO2 were smaller and had a lower relative growth rate when exposed to an elevated level of ozone-induced reductions, or in situ photosynthesis at ambient CO2. Back up. Elevated ozone-induced reductions in situ photosynthesis at ambient carbon dioxide. In other words, the current. In other words, under a concentration of carbon dioxide equal to present atmospheric concentrations, the presence of ozone caused stunted growth in the test plants. However, and this is where it gets interesting, quote, examination of the interactive effects of carbon dioxide and ozone revealed that elevated carbon dioxide reduced the deleterious effects of high ozone on both photosynthesis and growth. I mean, so we could go on. I mean, I have page after page documenting the beneficial effects of carbon dioxide. And nowhere has this been refuted. It's just ignored.
It's never discussed. It's never.
No, it's never discussed. It's ignored. So maybe by doing this, we'll stimulate some discussion. In fact, maybe at some point when we get some time here, we could put together a reading list for those people that are serious and really do want to learn about this, because it's very important. And the whole climate crisis narrative is being used and will continue to be used as a mechanism of social control.
Is there anyone that we could approach to talk with you about it on the podcast that would take the other side? Because pretty regularly we get comments in the videos, well, it'd be good if Randal had somebody to, talk the other side. But I know we had one of our videos recently, and you brought up how people said you were cherry picking, right? But the other side's cherry picking also, and you're kind of picking up the stuff that they threw on the ground and ignored.
I mean, What are they going to say? Are they going to, they can't refute the stuff I've just presented here.
I don't think so either. So yeah, that's part of why we don't have somebody here to pick up the other side, because they, they can't refute it. Right.
Right. The other side is what's out there everywhere you turn in the mainstream media.
Misinformation, disinformation, stretched
in fact,
of
Julie picked up this book. It was on a $1 book rack over at Emory, and she thought it would be fun to look at. So she picked this up. Now, this is by Dr. John Cook, as it's a Dr. John Cook. This guy's a cartoonist. So here's the book. And when you see this, you realize how they're taking this complicated discussion that really has many nuances and lots of perspectives on it, a lot of detail, and they're reducing it to a kindergarten level. And this is what's being offered for mass consumption by the people who don't really have a framework for thinking about these issues. So I'm going to hold the book up here.
Oh, yeah.
Cranky Uncle versus Climate Change. So it's like anybody then who raises any doubt or question or alternate narrative, not completely disregarding their credentials, whether it's a Judith Curry or a Roy Spencer or a Richard Lindzen or a William Happer. The list could go on of distinguished scientists that have brought up one problem or another or one point or another about the climate crisis narrative. But they are all being reduced, hundreds of them, literally, to a cranky uncle.
Cranky uncle.
Yeah,
the cranky uncle.
The ultimate straw man.
I think we're going to have to bring some of these memes together. And what I'm picturing now is the cranky uncle with snorts of derision. Actually, it's the cranky uncle who's questioning.
Yeah, it should be cranky uncle versus snorts of derision. That's the book we need to make.
Yeah, there we go. It's the cranky uncle versus, yeah.
Yeah.
So I shall take on the mantle of the cranky uncle.
All right. Cranky Uncle Randal.
We could go through this because...
Why do you hate the planet, Randal? Why do you hate all life on Earth?
Well...
We got our own book report coming here on Kosmographia.
There we go.
First one, Cranky Uncle.
Cranky Uncle.
Oh yeah, so here's the first page here. Now this is what they're going to accomplish with this book. Oh.
Yeah, over here.
Wrong monitor.
Oh man.
Orange hair guy.
Yeah.
Here we go. Making sense, damn it, of climate science denial. All right. So with that one throwaway accusation, they get around having any kind of real discussion. You see, anybody who questions this narrative is engaged in science denial. And yet here is irony of ironies. Who's really the ones in science denial? That's why I've got this whole article that I'll be posting, wrote years ago, called Who Are the Real Deniers? Who are the real deniers? No, it's not the cranky uncle. It's the experts. It's actually the politicians who are writing the summary for policymakers of the distillate, which is the distillation of the science produced by actually some good scientists who, working in good faith under the auspices of the Intergovernmental Panel on Climate Change. However, what's happened is that if they put out a politically incorrect view and then they stick with it, they usually lose their position in the crew of approved scientists. How much more time do we have?
Well, what does it get back to? The budgets and getting grants and getting the money to do their studies. Yeah, we got 10 minutes.
Okay. Then I think maybe what I shall do is jump into.
But it's like they're denying to actually report the real science.
Well, yes,
that's what the denial is going on.
You got it. I mean, that's it right there. Okay. So this was, in terms of somebody presenting the other side, this is an example of a challenge that I got from someone. And this is like 8 years ago. I think it was in 2015. My date here on this is August 31st, 2015. And this was based upon somebody was challenging me about, the guilt of the fossil fuel companies, right? And that's still a thing that's ongoing, to try to get climate reparations from the fossil fuel companies. So there's a whole gaggle of lawyers now that are,
right,
wanting to, like vampires, wanting to feed.
We need to punish you because we bought all of your products.
Right. So somebody is asking me about, Exxon and some of this stuff that they were doing back in the 70s and the 80s. And this is what my response. He was quoting an article that came out in mainstream media that was entitled "A Giant Corporation Lied About Science and Got Caught." Okay. So I say, when I looked at the work of these corporations that they supposedly, the computer models that they were generating way back then, that supposedly was their foray into the science and any predictions or prospects as to the consequences of increased fossil fuel. I mean, of carbon dioxide, they were looking at that. Yes, they were absolutely looking at that back in the 70s and the 80s, right? So what first struck me, and this is my response to this guy, after reading through the reports of actually procuring the original reports that Exxon and others came out with, okay? That's what I'm referring to here. What first struck me is that their work relied on computer models and were exploring worst-case scenarios. Given that current computer models have failed to accurately represent what is occurring now, particularly in terms of the divergence between projections and actual global temperatures, the computer models from the 70s and the 80s must have been notoriously inept at producing realistic projections of the future. I think that at least some of the scientists involved in this realized that there were too many variables to determine precisely the role of CO2 to any high level of confidence. What I see here is too typical of the fearmongers who are trying to paint a picture of some vast conspiracy to deny science, when what they mean by science is big government-funded, officially sanctioned science that was created in pursuit of an agenda that does not allow dissent or alternate points of view. The United Nations Framework Convention on Climate Change is pretty unambiguous in its mandate to the IPCC to make the case for anthropogenic climate change to the exclusion of all other factors. And given that congressional investigations have revealed that Exxon contributed only about $20 million to various groups over a decade, only some of which had anything to do with climate change, and this was the supposed primary source of funding for the nefarious AstroTurf groups that it is claimed are misleading the poor, gullible public, I would suggest that one considered the billions, yes, billions, that the global warming zealots have received in one form or another in the same time period. There's a lot more I could say, but due to constraints of time and space, that will have to wait for now. I will only say that the treatment of this disclosure by the pro-warming factions is a prime example of propaganda in the service of an agenda rather than attempt to understand the reality of the situation. To which I got a response from, this was posted online. Now I got a response from a Democrat activist, okay, who I actually knew, Madam. I won't mention his name here, but it's not important. But he was a Democrat activist. In fact, he even ran for a local office as a Democrat, and I think he got it, like as a commissioner or something. Anyways, this is what he said. Randall, I'm quite shocked at what I see here. Not the further accumulation of evidence that the fossil fuel industry has long been aware of and funding denial of anthropogenically caused global warming, as this has long been obvious to anyone who understands the fundamentals of climate and the simple notion of gases trapping heat in the atmosphere, along with the simple fact that money corrupts. How could it not, as you once said to me? No, what's astonishing in your denial of this wealth of science and evidence of both climate change and corporate malfeasance in favor of a conspiracy theory on the part of government, rather than the megacorporations whose monetary incentive, combined with their corporate muscle, simply cannot logically be denied. Now, if I grant that, then I would also probably have to accept the fact that large corporations that are receiving billions in subsidies and money to develop green energies are going to be guilty of the same thing, are they not?
Yeah.
Boiled down.
My government doesn't have any muscle or any money to be, right? They're totally innocent of that kind of stuff. They don't do conspiracies in the government. That's not what happens in government, right?
So then this is how he concludes. Boiled down to the essential analysis, your convoluted reasoning here does not withstand comparison to the available facts and information, though you may simply deny them. In short, you're wrong about this. So I say, blank, at the outset of a discussion, this is my response to that. At the outset of a discussion of this important issue, I would request of you to first provide the evidence for fossil fuel industry malfeasance of which you speak. You say, in quotes, further accumulation of evidence that the fossil fuel industry has long been aware of and funding, denial, etc. End of quote. I would be interested if you could supply details, specifically the money trail and where it leads. Which scientists received payoffs, and most importantly, some examples of fraudulent science funded by this money. You say that this is obvious to anyone who understands the fundamentals of climate change. Really? The potential of CO2 to influence the climate has been recognized long before Exxon funded some research in the 1980s, going all the way back to Svante Arrhenius in the late 19th century. And then I reference on the influence of carbonic acid in the air upon the temperature of the ground, which appeared in the Philosophical Magazine and Journal of Science in April of 1896. So now, Having gone through the supposed scandalous documents purporting to prove Exxon's disreputable behavior, I find virtually nothing of substance. I will repeat, they funded several in-house computer studies to try and predict the long-term influence of CO2 on the climate, and realized what many, many scientists outside of the IPCC have realized, and not a few inside, that the climate system is chaotic and not amenable to simple, single-parameter computer projections, not now, and certainly not in the 1980s. They acknowledge that there could be consequences to the unrestrained addition of CO2 to the global atmosphere, but at the same time we're confronted with the enormous complexities of integrating multiple factors that could drastically alter the outcome of their models. Your entire response to my comments is a statement of opinions. I would like to see some hard facts. I do not agree that money has the potential to corrupt. So if Exxon's paltry 20 million or so has corrupted climate change science, how about the $7 billion plus assets raised by Generation Investment Management, which stands to handsomely from global warming remediation schemes such as cap and trade? How about the $300 million pledged by Google to Solar City, one of Generation Investment Management's investments? You know, Generation Investment Management is Al Gore's company, right? In late February this year. How about Tom Steyer's nearly $100 million to Next Gen Climate, an unabashedly pro-global warming group? How about the U.S. government's yearly subsidies of $2.5 billion to the Global Change Research Program, a gigantic pro-warming bureaucracy? To dispel any doubt as to what their position is, here is a quote from the intro to their National Climate Assessment Report. Quote, global climate is changing. Most of the warming of the past half century is due to human activities. Some types of extreme weather are increasing, ice is melting on land and sea level is rising, end of quote. It then goes on to describe a litany of all of the ills that are going to befall us if we don't turn over the control of all energy production, distribution, and consumption to the government. The above list barely scratches the surface of the vast complex of vested interests that stand to gain through implementation of carbon remediation measures. I've not even touched upon the billions that flow to various environmental groups that promote global warming hysteria. I'll get back to that. And so this is only part of my response. I challenge them on multiple fronts on extreme types of weather. I would challenge you to show some examples, hurricanes, floods, droughts. And then I ask this question, are we seriously supposed to believe that complicated natural variables that have driven extreme climate change over and over again, long before significant anthropogenic carbon dioxide influence, have suddenly, in the 20th century, ceased to operate? Is sea level rising? Well, yes, it has risen roughly 8 inches during the past century. This is about the same as the century before. It rose nearly 400 feet at the Pleistocene Holocene transition circa 12,000 years ago and has been fluctuating up and down ever since. Not infrequently, it has stood many feet higher than present. Are we to assume that sea level would never change, absent an anthropogenic influence? So, yeah.
Well, it sounds like this person, is just a subject of brainwashing, more or less. He's not doing the research.
No.
He's not reading the evidence. He doesn't have a comprehension of the terms like you do that can understand it and compile it and collate it and regurgitate it back. He's just coming from a perspective of what he's heard and the big picture view. I'm guessing it's a he, but
it's a he. Yeah.
Yeah. So I love hearing that, man. Your ability to put those things together and argue back with people is excellent, and it's really reminds me of why I started hanging out with you in the first place, because when you presented to the group, it was like, all right, this guy's different. He knows the papers, he knows the guys' names, he knows the years, he can state quotes, he's got his facts straight, and yep, I'm glad I stuck around, because you're still doing it, man. That's really impressive.
Well, thank you, Brad, and I just want to reciprocate and say I'm glad you stuck around. I think it's been a profitable.
I'm glad you stuck around too, Brad.
It has been challenging and trying at times.
Of course.
Sometimes.
But
evil Brad.
Nothing that I can't handle.
You can handle it. That's right, of course. Yeah, good stuff.
But yeah, that was, Randall, that was fantastic. And I have noticed, briefly, I know we got to end here, but I have noticed this, and maybe I've mentioned it before, but if you try to engage people on this stuff, you say, well, where is the evidence that humans are causing climate change? Then they start showing you evidence for changes.
Yeah.
And I'm like, okay, so you're showing me that things are changing, but where's the evidence that people are causing it?
Mm-hmm.
But they think that part is just taken for granted. If change is taking place, it is humans causing it.
Yes.
Right. So,
but then when you
actually, part of the definition now.
Yeah.
Yeah. And when you actually look at the history of changes in the climate, what you see is that what's happening now is no different than what was happening.
That's what I'm saying.
A century ago, a century before that, that the climate, the primary characteristic of the climate of this planet is variability.
Variability, that's right, yeah.
Constantly.
Yeah. It really reminds me of the Aztec
That's
priests.
denier talk.
Yeah. The Aztec priests that knew from their astronomers that there was going to be a total eclipse, and then they're trying to create the impression that they're somehow in control of that. Yeah. And it's, to me, that it's like that.
Right.
We're just taking a natural phenomena that's been ongoing, and we've looked at this. And the thing of it is it's our examinations of this stuff been relatively superficial.
This is the new apocalypto.
Yeah, so you're like, well, how do you, if they're telling you, they're controlling the skies, or how do you know that? Well, did you see the eclipse?
Yeah.
Okay. That's not.
So there's a hurricane. Yeah, hurricanes. We find evidence of hurricanes going back millennia, and many of them far more intense than we've seen anything of the last few decades, for sure.
Yeah.
And we've talked about some of that evidence, how you can see, when there's intense rainfall or storms, for example, there'll be more runoff from rivers and creeks into lakes and ponds. And that creates a record that's clearly discernible, right? I mean, we can see the effects of hurricanes and storms, on coastlines all over the world. And we can look at those, and we can see how modern hurricanes affect coastlines by, storm surges bringing material on land. But then we can also see the same type of evidence from events past. And what do we see, lo and behold, is that events in the past have many times been much stronger and more intense than anything we've experienced recently. So, so it goes. It's crazy that so many people have bought into this, that there's a hurricane, there's a drought, there's a fire, there's a flood, as there has always been. And now they've taken the weather. This is what they've done. They've taken the natural variability of the weather and they've weaponized it.
Yeah.
Unless you're a climate denier, you're not allowed to use it.
That's right.
You can't mention the weather.
Stay out of it, cranky uncle.
Our ability to measure it and report about it is vastly increased.
Better. Yeah.
So that's why everybody's convinced.
As a final note, let's look at, politically in America, who's bought into it and who's promoting it. Pretty much 100%. You can't deny this. The Democrats. the posturing liberals who aren't real liberals anymore. They're just worshipers of an almighty state, and whatever comes from the state-approved experts is gospel. But the fact of the matter is that that's where it's coming from. And even the rhinos on the right, who don't say much about it, are not promoting the agenda. In fact, they're the only ones politically who are questioning the narrative. But in my opinion, not nearly enough. That would be my criticism of the right wing, the Republicans, is that their objections to this bullshit is so lukewarm. And that they're not standing up and calling it out for what it is and saying this is a complete scam. Because that's what it is. I spent 20 years before I wanted to admit to myself, well, maybe there's a genuine concern behind some of it. And I still think there is, but that doesn't now change my impression that the whole thing is just another big scam being perpetrated upon us.
It's about control and it's about money.
Yep. Well, about control and about money. And, let the market decide. But we're all going to see now, what comes of this, interestingly, because we may very well have a ringside seat to the next industrial revolution.
Yeah. Well, that ought to be fun.
That would be that's very possible. I mean, our man is in India right now trying to negotiate a licensing deal. So let's hope that something comes of it. Because if it does, guys, we're off and running on another level. All right. So.
All right. We're wrapping it up there.
Let's wrap it up.
Wrap it up. That's
Great
all,
stuff.
folks. We're wrapping it up. Thanks, Randall. That was a great show. Appreciate it.
Thanks. There'll be more. There'll be more. I mean, we got a lot more, and we'll probably spend a couple more episodes really laying this stuff down and trying to anticipate the things that people might say in objection and head them off at the pass.
All right.
Because there is pretty much a response to every objection I've seen up to this point. There's an alternate response. So,
all right. Once again, randalcarlson.com for everything Randall related.
That's right.
Sign up to the newsletter. Keep an eye on the website and the newsletter for updates, trips, tours. They got one coming up that's going to be done by the time this comes out, but there's more coming. We got Scablands, Montana. And
exciting stuff.
Yeah.
And also some videos by Malcolm going to be on our video platform partner, howtube.com.
There you go.
There we go.
Coming soon.
Final mention, just to remind people that there's a website, Sacred Geometry International, fraudulently and illegally selling my work. So spread the word if you can. Anything that you can do to get that message out is helpful and appreciated.
That is not Randal Carlson.
It is not Randal Carlson. But people have been telling me recently that they've been buying stuff from there and then finding out that it's not me and getting really upset about that.
Yeah.
And of course, can't blame them. How do you think I feel? Okay.
All
Thanks,
right.
guys. Enjoyed it.
In these days, that's hidden will be revealed also.
Yep.
Good night.
See y'all. Good job, Randall. Great stuff, man.
Thanks, guys.
More to come. 96 out.